Hello, today we're going to discuss a challenging question for JEE aspirant. Here the question reads something like this. Two identical point charges are moving in free space. When they are 60 centimeters apart, their velocity vectors are equal in magnitude and are making an angle of 45 degrees from the line joining them as shown in the figure. If at that instant their kinetic energy is equal to their potential energy, the distance of closest approach between them. This diagram is given in the figure. You have two positive charge and the velocity vectors are this, making an angle of 45 degrees with the line joining them, and the distance between the charge is 60. Now see, as they are moving, you see that they will experience an electrostatic force like this, and due to this velocity it will move in a trajectory like this. And when they are at this point, then they don't have any velocity along x-axis and they will have only velocity along y-axis. Now see, the initial velocity is being resolved into two components. This component becomes v cos 45, this is also v cos 45, this is v sin 45, this is v sin 45. Now as they are moving here, the y component of velocity exists but no x component of velocity. After that they will start moving away from each other. So this is the distance of closest approach. Here as per the question you can see the initial potential energy of these two charges k q square by 60. Initial kinetic energy of both of them is half mv square plus half mv square, that is mv square. Again it is given that initial potential and kinetic energy are equal, so you can equate these two and therefore kq square by 60 is mv square. Now from this equation we mark this as equation 1, and from this equation we have kq square is equal to 60 mv square. From the distance of closest approach is r minimum. Let's say that this distance of closest approach is r minimum, then it will only have y component of velocity which always remains constant. Therefore at this instant the potential energy, final potential energy is k q square by r minimum. Kinetic energy is half mv by root 2 whole square plus half mv by root 2 whole square, that is mv square by 2. From conservation of energy, we have initial total energy is equal to final total energy. So if we put all these values, we are getting this as the expression. Now, as I have told that initial potential energy is equal to initial kinetic energy, so this can be substituted as mv square. Now, this kq square by r minimum from equation 2, kq square is equal to 60 mv square, so that is 60 mv square by r minimum. Here throughout, mv gets cancelled to 1 plus 1 is equal to 60 by r minimum plus half. And therefore 60 by r minimum is 2 minus 1 by 2, that is 3 by 2, and therefore r minimum comes out to be 40 centimeters. So this distance, the closest approach will be 40 centimeters.